Hi, I'm Janielle Rosete, and I am an astronomy student, and I would like to conduct a study regarding the scientific reasoning skills of my fellow astronomy students. And today, I'm going to discuss my capsule research proposal. Rationale. Some of you may have noticed that scientific reasoning has always been a challenge to every Filipino student. This can be proven by their performance at the 2019 National Achievement Test, wherein their ranking in science is way below among the participants in other countries. Given the points and situations I've mentioned, I was motivated to conduct a study that aims to test the capacity of astronomy students with their scientific reasoning abilities. Objective of the study. As a researcher, I want to know how astronomy students deal with scientific reasoning. That is why the objective of this study is to assess the scientific reasoning ability of astronomy students. Statement of the problem. Hence, this study aims to answer the following questions. First, what is the level of scientific reasoning skills of astronomy students during the start of the semester and at the end of the semester? Second, is there a significant difference between the scientific reasoning ability of astronomy students from the beginning of the semester until the end? Significance of the study. This study will mostly benefit the following. The DOST will be given a basis in instructing the schools to take actions that will help improve the scientific reasoning ability of the students. The school will be able to carry out more programs and lectures regarding scientific reasoning. The teachers will be informed about the cases of the students, thus they will be able to create new teaching strategies. The students, who are the primary beneficiaries of this study, will be able to fully recognize their problems concerning their scientific reasoning ability and can therefore think of ways to help improve and develop it. The researcher will have a broader knowledge and understanding regarding the scientific reasoning ability of astronomy students. Moreover, this study will provide additional background to future researchers who want to pursue their own researches about this issue. Theoretical framework. Scientific reasoning differs from other skills in the sense that it requires additional cognitive resources as well as an integration of cultural tools. According to Lawson 2004, scientific reasoning pattern is defined as a mental strategy, plan, or rule used to process information and derive conclusions that go beyond direct experience. Piaget's theory of cognitive development, 1936, describes how a child establishes a mental model of the world. Piaget disagreed with the idea that intelligence is a fixed trait and considered cognitive as a process which occurs due to biological maturation and interaction with the environment. In general, these theories and models represent that scientific reasoning ability involves problem-solving techniques, mental processes, experimentation, and evaluation of evidence. Methodology. Research design. This study used the descriptive comparative method of quantitative research. This method is divided into two parts, the descriptive and comparative approaches. Sampling plan. This study used the total population sampling, According to Dr. Ashley Crossman of 2018, total population sampling is a type of purposive sampling technique that involves examining the entire population that has a particular set of characteristics. Instrumentation and data collection. I utilized the classroom test of scientific reasoning established by Anton E. Lawson to gather data from the respondents. The test is composed of 24 items. It includes questions regarding the 6 scientific reasoning abilities: conservation of mass and volume, proportional reasoning, identification and control of variables, probabilistic reasoning, correlational reasoning, and hypothetical deductive reasoning. Furthermore, the distribution of tests was conducted by myself. I gave the tests at the beginning and at the end of the semester, and retrieved them after the students have accomplished answering the tests. Tools for data analysis. Assessing the scientific reasoning abilities, the correlational mean was utilized, mainly focusing the large sample studies for which the z-test is appropriate. Presented methods of analyzing what were called correlated samples using a modification of the familiar two-sample z-test. These methods calculated the standard deviation of a difference between means, according to Guilford and Frucher, 1973. This assessed if the curriculum of the BS Astronomy course affects the scientific reasoning ability of the students. Managing risk. The potential risks which might delay the research process are the following. First, the schedule of administering tests for correlational sample. Second, the mortality of the sample. Scope and the limitations. The scope of this study is the population composed of all first to fifth year students in the astronomy course of Rizal Technological University. Ethical considerations. To establish and secure ethics in conducting this study, I strictly observed the following. First, the identity of the respondents was not disclosed. Consent from the respondents was taken, and appropriate permission was ensured for the usage of the data given. To ensure both the safety of the respondents and the quality of the data, confidentiality was observed. Secondary data from any source was acknowledged with proper reference. A communication letter was presented to the concerned authorities. That's all. Thank you for listening. Always remember, spread love, not hate, and stay hydrated. Again, this is Janielle Rosete, signing off.